Okay, let me start. Good evening, everyone. A warm welcome to today's upskilling session of UiPath Agent Hack India Student Edition. I'm Vidya from UiPath Student Developer Program. Today's session focuses on prompt engineering and adaptation led by Palani. A small introduction on Palani for the new attendees. Palani is four times UiPath MVP, agentic AI strategist, and technical architect at Novo Nordisk. With over 8 years of hands-on experience in automation and AI, Palani blends the precision of a mechanical engineer with the creativity of a coder. He is a certified UiPath trainer, an active contributor to the community, and a mentor to many aspiring students and professionals. Palani, over to you.
Thanks, Vidya. Hello, everyone. Thanks for joining today's session. And today I'm really interested to share some uh, topics that is always something I have wondered how to use for a very long time. Because right from the time when we had this ChatGPT or any LLM model that you use in the market, we just simply write a message or a text or an input to it, and then it is able to understand and respond back to us. But I was so fascinated about the science or the technology behind the text, like how it is working with that LLM model and how it is able to give us a kind of a response that we are looking for from that LLM model. So today we'll be looking at that kind of a concept that is so called prompt engineering, which might sound very simple, but it has so much of power in terms of manipulating an LLM model the way it gives you the response. So we'll be looking at prompt engineering, the core principles and the types, and how it is going to help in terms of building an AI agent system and so many things. And we also have a quick demo of agent builder with this prompts coming in place. So I'm pretty excited for the day, so let's get started. I'll quickly share my screen. Okay, I hope you can see my screen with the
Yes,
presentation mode.
yes, it's up.
Great, thank you. So again, as I was telling, today's topic is going to be on prompt engineering and the way we adapt it. So let me start with a quick introduction. I know many of them have seen me with the previous session, but for someone who is joining this session for the first time, to give an introduction about myself, I'm Parni, based out of Bangalore, and I'm a four-time UiPath MEP. And I also lead Chennai chapter with the background of specialized AI professional certification and advanced RP developer certification. And I'm also a community trainer, come UiPath's forum moderator and a leader. And I'm also there with the LinkedIn Top Voice Award. So you can scan this QR with your mobile and then you can follow my page in LinkedIn and you can reach me out for any discussions that you want to have with AI agents or anything about automation or AI powered automations. Great. I'll share this QR with this link in the chat. You can scan it or you can click on the link and then you can reach me out through the LinkedIn. Great. So coming to the agenda part, we'll look at the core principles of how we differ between AI agents and agent workflow to just have a quick recap, and what is the prompt and how it is impactful. And we also look at types of prompts, and we'll also discuss more about prompts focusing on building an AI agent. And when it comes to that topic, we'll be discussing about prompts and arguments. And at last, we'll also look at a quick demo with Agent Builder of how we will be defining these prompts in Agent Builder. Okay. Okay. So seeing this once again. I'm seeing this pop up. Just give me a second. Um, that's really fine. Okay, great. So let's look at the core principles, starting with a difference of what is agent and an agentic workflow. Like previously, if you have been through my sessions, we were discussing that agentic AI is divided into two categories. One is AI agents, another one is agentic workflow. AI agents and agentic workflow. So let's see what all falls under AI agents and what all falls under agentic workflow. So if you see the criteria at the left side, if there is any process that comes with decision making, like classifying, summarizing with the help of an LLM model, you literally use it or tag it under the category of AI agents. It's not a workflow. Clear? So if the same process comes with an additional set of steps with a structured data process, like extracting volumes from a contract and putting it in a different software like SAP or Oracle, which involves a number of steps, right? Like a flow of process or flow of steps, then it comes under the category of agentic workflow. Clear? And then if it is like a multi-step automation, I was telling you, if you're using API or a browser, like an UI interaction within that flow, along with an LLM model, then you again consider that as an agentic workflow. And if it's like unstructured data reasoning for a specific scenario or a specific set of a process, or a specific task of a process, then you call it as an AI agent. And if it's like, um, let's say you doesn't end up with just one task or maybe two, three tasks. Apart, instead of that, if you're working on a process and if that process is going on a repetitive cycle like an automation, and you have that agent incorporated within the repetitive cycle, then it's so-called agentic workflow. Then coming to the last one, if it's more of a domain-specific action with a knowledge source around, then it is more of an agent. So um, to keep it very simple, if any system is able to make a decision by itself without relying on a human input or without looking for a human decision making, and if it's able to create a decision by itself and then solve it, then it is so called as agentic AI system, right? Under that, if that agentic AI system is going to work on, let's say, one or two tasks or a specific software or a specific tool like an assistant, then it is so called as AI agents. And if the same AI agents is used like multiple AI agents across a set of process between different systems and different applications, and that is so called as an agentic workflow. Clear? So with that note, I want to emphasize another point that AI agents are not agentic workflows because those two are different from each other. That's why they are being categorized as two different things under agentic AI system. So let's say when you can go for an agent, like just read through this one by one, you'll be able to connect the dots. Consider agents as a components of a workflow. That's what I was saying, and not as a replacement of a structured automation. So let's say you have an automation with 50 steps, and if there is one step where you need a human decision making involved, and you can replace that human decision with an agent, then that solving that human decision making with an agentic system is so called as an AI agent. And as that AI agent is placed in between these many number of steps before and after, it is so called as an agentic workflow, right? And that's what the next 2 point is about. Overloading an agent with too many responsibilities will reduce its accuracy and increase the complexity. So you really need to focus on what needs to be replaced with an agent. You shouldn't literally replace an automation with an agent. That doesn't work. you can have an automation and then you can solve it with an RPA technology as it is. But if that automation with 10 steps, having one or two step with needs and human decision making, and if you're trying to replace that with an artificial intelligence, then it is so called as an agentic system or agentic solutions whatsoever. Only then you call it as agent is involved in that automation, else it's not an agent. Okay. So the best practice is to minimize agents' responsibilities by focusing on decision-making tasks rather than multi-step processing. Again, like just look at that one point by focusing on decision-making tasks. You don't need to literally change the complete automation saying that I'm using so-and-so LLM model, so-and-so AI tools, and I have built an agent tool. That's not an agentic automation, or that's not so-called as an agent system. If any step where a human decision is replaced by an artificial intelligence, that system is called as an agentic system. Okay. And when it comes to AI agents or agentic workflow, or it could be any generic topic on agentic AI systems, you need to understand how that LLM model is going to enable that decision making or enable that reasoning behind the whole. So for that, we need to know four different technologies, that is, four different terminologies like prompts, fine-tuning, priming, and retrieval augmented generation. So these four are the major backbone of any agent system. Maybe you can use one among them or two among them together to enable the LLM model to make the decision making and then make a process as an agentic process, right? So you need to understand what are these four and how it differs from each other. Maybe you can read through the rest of the columns, but I would really focus on its definition and purpose. So if you see the definition of prompts, it's like a specific instruction or questions given to a model to elicit a desired response. It's like you are trying to make a question or a statement to retrieve a response from that LLM model with the way you want. So you are drafting that statement, or you are drafting a question and putting to that LLM model to get a response. And that is what is so called as prompts. And when it comes to fine tuning, right? So let's say ChatGPT or Anthropic Claude or DeepSeek or Grook, any LLM models, those are like pre-trained LLM models. They are not fine-tuned LLM models. So then you need to understand what is the difference between pre-trained and fine-tuned. Pre-trained or like they are trained with a large corpus of data which are existing in the internet or like like books or Wikipedia. It could be of any data source where it is trained on a pre-trained data set. And on top of that pre-trained data set, if you are adding your own domain-specific knowledge, or let's say you are adding your own set of like data sets to it, and then training it further, then it is so-called as fine-tuned LLM models or fine-tuned data sets. That's what a process of training a pre-trained model on a specific data set to adapt to its particular task. So that once you train the pre-trained model with this, your own data set, you can ask or make anything out of it, like with relevant to the data that you have trained with. So that is what is fine tuning. And priming is a little different from fine tuning, where you provide the context or the background information to influence. Like you can add some data along with the prompt or data along with um, the LLM models that is involved so that it gets referred to that data set and then able to respond on a subsequent queries. But again, apart from this fine tuning and priming, there is another one called RAG, right? RAG works more on a semantic matching, right? So which means, um, how can I say it? Okay. So let's say you have a prompt given to an LLM model, and then you're asking a question, but LLM model may not have the data around that question. So you're trying to add an additional set of a knowledge base, which is more of a domain specific with respect to what your prompt is about. And then this question and the domain specific knowledge will get vectorized, and then based on the semantic match that it gives out, the LLM model use that semantic outcome and your prompt and then make a better response for your question. But now you might be wondering how it differs from priming then. Maybe at least to an extent, fine-tuning is different. You are training and then pre-trained LLM model to respond on a data or respond on a statement or a question with respect to the data set, right? But priming and RAG might sound little similar, but they are a little different from each other. Just look at the purpose here. So let's focus on the last two columns and third column. So purpose of priming is like to shape the model's response style or focus on prior input, right? Which is like RAG is different. Like it's like you are leveraging external data so but you can update it at any point. Like let's say you are getting a response from an LLM and you can even pass the same response again to a database or a knowledge source as a context. So that is what is retrieval in RAG is about. But priming is like you give it once and then you use it for the rest of the questions that you're having, right? That is what is priming is about. It's a little different in terms of the way you are using the knowledge base and the way you are updating the knowledge base. That's how priming differs with RAG. RAG is more like you can update it, you can pass it, but priming is just you pass it. You don't get an option to update it. That's the difference, right? So out of all these, we will be looking more towards prompts because these are like very large topics to discuss about. But today, to anyone who wants to use an agent, they will be writing an input prompt to drive that agent, right? So it's important to understand the different types of prompting, and that's what we are going to focus now. So before that, we need to understand the common usage of artificial intelligence, like to an extent what we know, people who have RP expertise or people who are AI ML enthusiasts, they know like AI could be used to a maximum of maybe in a chatbot or to extract document details and summarize it, or even to create some contents around it. That's what we have seen through, right? And but we need to understand how these AI will go hand in hand with the prompt engineering. So how the prompt engineering will impact this AI to perform the above three tasks, like it could be a chatbot, could be document extraction or content generation. But we need to understand how this prompt engineering influences that to get these things done. So let's understand what is prompt engineering is about. As I was telling you previously, it basically means you're creating a question or a statement to get a response out of an LLM model with the way you want. So this prompt engineering will help us to retrieve some data based on what we are giving, or we can let the LLM model to look outside and then give us some data. But then apart from this, you are enabling that LLM model to work on a specific question rather than making its own assumption and then hallucinating things. So that's where the prompt engineering plays a major role. And on that, we need to know what are the types of prompts now. So there could be many types of prompts, but you would have literally typed some text in a chat GPT, but you may not know what is that exact type is, under what category you are typing in a chat GPT or any LLM apps. So you need to know the type so that you can mention those prompts in a better way. So for that, we need to know what are the types available so that you can make those prompts in a very effective way. So let's start with types one by one, starting with zero shot prompting. So when I say zero shot, the two terms here, zero and short. Short is more like an attempt to do a prompt. But if you see zero, it's like you are literally not adding any external data or additional data to that prompt. And you are trying to use an LLM which may not have some details around the prompt that you are making. So you're not giving any additional inputs or you're not giving any examples, and you're literally asking an LLM model without knowing what that LLM model is capable of. So let's say you're asking ChatGPT, like, what is agentic automation? Of course, it knows that, but maybe you can ask, when is my birthday? But that LLM model may not know that, right? So you're just literally asking a question to an LLM model without any data around or without any examples around, right? Maybe you can take this simple example that I have stated here. What is an agentic automation? You're not giving any more inputs. It's just as simple as that. But then if you go for the next type, which is one-shot prompting, where you will be giving some kind of an additional input along with the prompt that you want to make it like a question or a statement. If you see here the example, what is agentic automation and how does it differs from traditional automation? You're adding some additional inputs so that the LLM model doesn't end up in just giving you the answer for agentic automation. It will try to give an additional input so that you can understand and then make use of that response in a better way. So that is what is one-shot prompting is about. Let's go for the next type, few-shot prompting. And if you see the previous type, you are giving only one additional layer of information. But if you are adding further more information, like two, three layers of information along with the prompts, then it is so-called a few-shot prompting. Let's see an example here. Describe agentic automation, highlights its key features and how it enables system to make independent decisions. And explain the role of agentic automation in enhancing business processes and including examples of industries that benefit from this technology. So you're adding more information like what you need out of that LLM model so that LLM model knows that you doesn't just look for what is agentic automation, but you also look for these details so that the LLM model can correlate and give you a proper response, which will be more informative and effective. And the fourth type, which is chain of thoughts. It can be a zero shot chain of thoughts. It can be a few short chain of thoughts. But let's understand what is chain of thoughts. The beauty of this is you can club all of these and then make it like a prompt. Let's say you can combine a few short and a chain of thought together as a few short chain of thought prompts. I can combine zero shot and the chain of thoughts. That is so-called COT, that is change of thoughts, right? You can call it as zero shot COT, something like that. You can also club these and then make a prompt out of it. That is what the beauty about. So if you see about chain of thoughts, you are literally letting the prompts or letting the LLM model to understand the prompt and then little bit it will try to deep dive a little bit and then give you a response rather than just giving you a straight away response with whatever knowledge it has. So you're asking the AI to detail its thoughts step by step, and based on that step by step and its outcome and the reason that it is coming up with, it will be able to give you the most optimal kind of a response from the LLM model. So you can see an example here. So if you see the previous one, I'm just giving the prompt that I want to know what is agentic automation, how it differs from the traditional, and what are these features, and so on. So, but here I'm telling, hey, I want to know about agentic automation, but I want you to take a step-by-step approach and tell me that how it is differing from a traditional automation, so that it will go on a theory of reasoning, and then it will try to go step by step and give you some information rather than just giving you a 3 to 4 line of a paragraph. That is what is chain of thoughts is about. And let's go with iterative promptings. So this kind of an iterative prompting will be very helpful when it comes to building an AI agent, because AI agent doesn't end up with just one prompt. So you might giving a prompt initially, and that LLM model will be using, and that LLM model outcome might be used again as a prompt to refine it further and then get an additional or an even more optimal output. So that's what this iterative prompting is. This is a process where you refine your prompts on the outputs you get previously, and then you have n number of prompts that you want. Like for here, I have quoted two prompts, like take a moment to analyze and then respond in agentic automation, covering its difference. And once that LLM model gives an output for me for this prompt, I'll try to mention another prompt saying that give more details and summarize the best out of it, so that it will take the previous output from the LLM model and then fine tune it, refine it, and then give me more details in a very summarized way. And that is something I can use it for the rest of the process and the steps involved in the rest of the process, right? That is what is iterative prompting is about. So another one is negative prompting. So before we go ahead further, let's just quickly recap what we saw so far. One is zero shot, where you don't give any additional input. You just give your prompt and expect an answer out of it, regardless of whether the LLM has some idea about it or not. You just ask it, it gives the answer. That is zero shot. One shot is like you give an additional information along with your prompt so that the LLM model will understand, okay, this is what I need to give, and this is what they're expecting, so that it doesn't give any unwanted details. And if you add a few more layers to that one shot, that is so called as few shot. And after that, if you're adding a chain of thought to it, and you're letting that LLM model to think through it step by step and then make a reasoning and then give you an output rather than just considering those few short of examples and then giving an output, you'll try to think through it one more time and make a reasoning and then get the best reason out of it. And then that's what chain of thought is about. And if this, let's say if you're using zero shot COT, and if you're using it like an iterative one, where you make a prompt, you get the output, and then you use that output again as another prompt and then get an output, and then you use that output again and then maybe as a prompt, or you can use it for the next set of steps in the process. That is so-called iterative prompting. These were the types we have seen so far. Let's go for the next type, which is negative prompting. And you literally, as the name implies, right, you will tell AI what not to do. Like instead of just telling what to do, you'll also say what not to be considered. Let's say if I have to add an example, I'll be like, explain about agentic automation and without getting deeper into the other branches of AI, because that is not needed for me. I just need what is agentic automation is about. So I'm telling the LLM, I need this, but I also don't want this. That is what negative prompting is. And hybrid is like, if you're combining any of these, it shouldn't be an iterative, but if you're trying to combine any of these like COT zero shot, COT few shot, COT negative prompting, then it is called hybrid prompting. As simple as that. Let's go for the prompt chaining. So, so again, this prompt chaining, similar to chain of thoughts, also adds a lot of value to build an agent, because when you are building up agent, you will be designing an agent to use LLM models at multiple stages, which means your task as a prompt has to be split into multiple layers. And that is what is prompt chaining. You'll be breaking down a complex task into smaller prompts and then chaining the outputs together to form a final response, right? That is what is prompt chaining is about. So this is again a type of chain of thoughts. So it's like you will be making them working on step by step and then creating a response, more of a reasoning theory. And this, whatever we have seen so far, like chain of thoughts or like iterative prompting, is little different from React prompting. So let's take two of these, like React prompting and COT prompting, that is chain of thoughts prompting. So COT prompting has an option to make a reasoning and then get the best response out of an LLM model. But it doesn't have an option to act on that reason. Let's say you are asking a question to LLM model and it is trying to reason that, and out of that one reason, it is not able to get an actual answer that the reason is demanding. So on that note, you need to do an action to solve that reasoning, right? And that comes only with React theory. So that is what is combination of reasoning plus acting on it. That is React. So So you might be wondering how this React will be able to solve that reasoning, like acting on it. So for that, this reasoning will have an option to look at an external sources and then solve that reasoning. Whereas in chain of thoughts, it doesn't come with an option to look for an external source and then act on it. It just gives a reason and gives an output, whatever that reasoning is able to do. But if it is not able to do, then it doesn't mind. It starts hallucinating and give you some random outputs. To avoid that and act on those, even those reasons which is not coming or which is not covered with that LLM knowledge base or pre-trained LLMs, then you need to have this React prompting. So that is what is reacting is all about. So if you see the last block at the bottom, React comes with an LLM that generates verbal reasoning, that is thoughts and actions. And it also tries to generate dynamic reasoning that allows for this updating the plans. So chain of thoughts doesn't allow you to update that thought. It's like it will try to reason it, but if it is not able to find an answer for that reason, it starts hallucinating. To avoid that, you can bring this React, where it will look for an external resource, try to solve that reasoning, and update that model or update that knowledge source. That is what like you can use RAG here, or you can use um, vector DBs here, kind of thing. So that is what is React prompting. So when you're using Chat GPT app, or when you're using DeepSeek app, or if you're trying to build an agent with a prompt, and when you're typing that prompt, you need to keep all these options so that you can use any of these type based on the scenario that you're trying to solve with an agent. So if an agent is trying to solve a more of a reasoning based scenario, then you can go either of chain of thoughts or React. Or if it's pretty simple that you are just instructing the LLM model to work on a specific task, you can go with the rest of the options like zero shot, few shot, one shot, or hybrid, or it could be anything. So you need to understand what type of prompting is needed and how we can use that type in an effective way to solve a process with an agent. Clear? The next time when you're prompting, keep these types in your mind so that you can think about, okay, I think this agent is demanding me a zero shot React. So then I need to combine these two and then draft my natural language prompt in such a way that it is able to make a reasoning and also able to act on it. So a quick example of or a difference between COT and a React. Just see the left side of the prompt. You are at the entrance of the maze. Think step by steps to find the exit. So you're just telling the LLM model to think step by step and give me the reasoning and then get me the best way to get out of it. And the final decision is something like this. And if you see the React prompting, you are saying like you are at the entrance of the maze. Think step by step and take actions to find that exit. Maybe while trying to define that step by step, if it is not able to get one specific step, then it starts hallucinating when it comes to chain of thoughts. But here, if it occurs that if it's not able to solve a step, then it tries to act on it. So if you can see the observation here, after moving left, you see a door to right, right? And that is what is, so you're trying to lead it outside and then you're trying to get an action out of it based on the reason that it's trying to build. It doesn't just end up with giving you the reasons. Okay. So if you want to take a screenshot, if you want to refer this later, you can do it. Feel free to do that. Anyhow, this recording will be there, but just for a reference. Now we have seen, I think there are many types still left with prompt engineering. Even to my knowledge, I see there is something called tree of thoughts and many other prompt types. But I don't want to go deeper into it, maybe on a lighter note to understand the type of prompts. And I have covered these types based on what I'm going to take you through with the next set of slides. So we are going to focus on prompt engineering more towards building an agentic AI solutions. So, and whatever types we have seen so far will really help you in terms of building an agent with a proper prompting. So let's get to that. So when you're doing a prompt to build an agentic AI solutions, there are some do's and don'ts when you're defining a prompt. It is just a simple natural language or a text, but still it needs some a way to approach it. Let's look at the do's. Let's say when you are writing a prompt, you can write a role to that AI. Let's say you are a customer support assistant, or you can write a goal specification like clearly define what that AI's objective is about, what it has to do. Like, for example, answer questions regarding product pricing and features. And you can also add some prompts, layers like outline necessary guidelines on what it has to do. So you are saying like keep responses under 200 words and avoid technical jargons. So if you see here the do's, you are literally writing prompts like what that LLM model or agent has to do with that LLM model, and then how it has to proceed further, and how it has to give a response, right? And let's focus on don'ts. It's like you don't need to put um, a strict output structure as it is. Like you shouldn't mention like respond in numbered list, and it can still do that numbered list, but it may not come as you expect. It can be of different format, and if you rely on a standard format, that may not happen, right? So it's better to avoid mentioning that. Rather than mentioning, you can get a response out of it and use that as a prompt, like an iterative prompting, and pass it to another LLM model to use it for the further steps of the process. So don't go and write any expected output format. Try to avoid that. You can do it, but you may not receive that format as you expect, right? And do not provide any sample inputs or expected. Again, it's the same note. So again, because the reason is you have already given that either as a knowledge source or as an argument. Let's say an RPA bot is running, it is giving me an ID, like an invoice ID. And with that invoice ID, I need to place an order in Coupa or any system. And I'm passing this invoice ID to an agent, and that agent is receiving this Coupa ID as an argument. And then using an LLM model, it is trying to interact with Coupa system with an API connection. So if you see, I shouldn't pass this ID as a prompt. It has to come as an argument. So avoid passing inputs like a value or anything as a prompt. Okay. And again, like avoid giving vagueness, like vague instruction that lack clarity. If you're not sure about a part of a prompt or a part of a functionality, then don't just mention that. Don't mention that as a part of the prompt because it might confuse the LLM model to understand the prompt and then act on it. So literally, like you can just simply avoid adding points where you don't have a better clarity. Okay. So let's see the core essence of prompts that you will be using when you are building an AI agentic solutions. So literally you have different types of prompts. You saw that types so far, right? But those types can be categorized further into two different prompts. It could be either a system prompt or a user prompt. So let's see what and all comes under a system prompt. So with this system prompt, you can use any types of prompting model or a category or a type. With that type, you have to define only certain things and only then it is called as a system prompt. So let's say if you're trying to define the role of that agent, if you're trying to define the goal of an agent and add further instructions like step-by-step instructions, like a few short prompting. And then you're adding a tool usage instructions like a chain of thought prompting, and then constraints like negative promptings and error handling and escalations. So if you define these prompts with those types that we saw so far, then it is so-called system prompting. And when it comes to user prompting, you won't define anything like what you did with system prompting. You will just highlight the input variables and you will highlight the expected output variables. Here we are not mentioning the input values. We are just mentioning input variables or arguments, which is different from values. Value is a value, and a variable is a bucket that stores that value. So it's completely different from each other. So if you can use any type of, again, prompting here, even with user prompts. But with user prompts, you will only refer to the arguments or arguments or the variables that you want to pass to a prompt. That is what is user prompt is about. And you can use some text based on the types of prompts that you have seen so far. And then you can use some uh, variable within the text as a placeholder so that it becomes a user prompt. Let's look at it a little bit more about what is this system prompt, what is this user prompt, but I want you all to understand what all you can consider under a system prompt, what all you can consider under a user prompt. Okay. Okay. System prompts allow you to describe in natural language the role, goal, and constraints of an agent. So when I say natural language, you can use any types of prompting here, and then you can define the role, goal, and instructions. And you can literally tell that LLM model or an agent to follow the instruction. And then you can tell how the tools has to be used, how the escalation has to be formulated, and what is the context and all those stuffs. So this system prompt helps that agent to form a plan that it uses and adapts over time from interactions with tools, robots, and humans. A good system prompt suggests a sequence of steps and addresses certain cases and tells agent when it should call tool and raise escalations. Okay, I hope you got about what a system prompt is about. Let's focus as user prompt. Again, user prompt is allowed you to structure how the input and arguments has to be passed to an agent. So far in the system prompts, you would never use any arguments or variables. It is just an instruction on what that agent needs to do with that process or what that agent needs to do with the rest of the components within that agent. But when it comes to user prompt, you still use natural language, but you also tag those variables or arguments so that agent can understand this variable has to be used in this way with the natural text that has been added, right? So you can see the syntax at the last point. You can use example input, which is actually the argument or the variable that we are getting from that is defined, or an argument that we are getting from another agent or another RPA bot or another LLM model, and you are trying to pass that as a prompt with some natural text before and after to that argument, so that the next LLM model or next agent will understand that this value has to be used in so and so way. That is what is user prompts about. So let's see how to pass values with user prompt, because I know you would have understand what a system prompt is. It's plain text prompt where you'll be sharing the role, goal, instruction, all those stuff, step by step instruction, all those stuffs. But with the user prompt, you'll be passing some values also as an argument or as a variable. Let's see how to do that. So you saw the syntax in the previous slide itself, but the catch here is agent always user prompt as a natural text, but unless and until you highlight that argument, it will not consider by the agent. As simple as it. You have to literally explicitly mention that arguments. Okay. So here is a quick example. Here you can see some tags like an XML tag before and after uh, covering an argument, like that is email to with two curly braces to the left and right. So email to customer email and reply email ID are the arguments, where email to is an out argument and customer email is the in argument, and reply email ID is again an out argument. So you literally don't need to add these tags before and after the arguments. You can just mention the argument and then use it along with the natural text in the user prompt so that the agent will be understand how to use that argument with the help of the natural text that you have covered around, right? Okay, so I just want to take, we have a good amount of 10 minutes. So I'll quickly take you through a quick demo. I'll stop sharing my screen and then I'll open the agent builder and then I can tell you how that system prompt and user prompt will help you in terms of building an agent with Agent Builder. Okay. Agent Builder is still in a preview state and it gets public by this April 30th. And you'll be able to access it if you have a staging account, like an enterprise account. So just have a look at it and see how this agent builder is going to be. And once you get an access, just try it out and see how you can leverage these promptings and methods to build an agent. Okay. I'll stop sharing screen for a few seconds. Okay. I'll share my screen again. Okay. So this is what the agent builder will look like. Attention, please. So this is how the agent builder of UiPath will look like. And you can see many tags here. Let's go one by one and maybe not deeper, but I'll try to explain you with the time that we have. So with the left side, you'll be mentioning the model that you want to choose. It could be Anthropic, Claude, or GPT-4o, 4o Mini, or anything. So these are the versions and the dates that they got released, and you can choose any of these models now. And in future, UiPath is planning to come up with additional models that you want. So this is very initial stage. So they have opted, I mean, they have enabled with these 5 models, which are very popular in the market. And you can also set the temperatures. Now you will be able to understand why we discussed about temperature in our previous sessions. So for anyone who haven't watched our previous session on Introduction to AI Agents and the fundamentals of AI ML and agentic architecture, I would strongly recommend to get into the community page and look at those recordings. And there we have discussed about this temperature and importance of temperature and the importance of tokenization here. So definitely read through it so that you will understand what is the importance of having this temperature and how it adds value to your agent. Okay. And coming to the next section, which is general about name and the description of that agent, and you can add the prompts. So you can literally see the system prompt and user prompt section here. So system prompt is something where you will be mentioning the instructions, role, and goal, and all those stuffs. So when you're mentioning a role, it's like when you're mentioning instruction, you need to add some tag like this and so that the agent will be able to understand. Let's say I'm adding a role to it because I didn't add role when I was preparing this. So you are a customer agent who will be uh, processing email request and um, orders from those emails. So you're literally telling the role of the agent, like what it has to do. And then you are adding some instructions, like what it has to do. You will be enabling these instructions with a set of tools like let me read through the instructions so that you can understand how this can be enabled. Okay. So first you need to read, you are telling the agent. So here is the beauty. See, previously you would have built this as an automation, right? So you would have set of activities, and then at one point where you might need some AI to make a human AI to make or replace a human decision, where you will be reading through the email and the order details and make a sentiment analysis or NLP entity recognitions and then get the extracted data and process it. And you might be needing some human intelligence to validate that outcome. And so here you are replacing a part of that human intelligence in understanding that output or email to proceed with the next set of steps with an agent here. And for that agent, you are passing the rest of the steps also as an instruction or as a part of its process. So here you are passing information that you need to read through the email carefully and then identify the order ID. Once the order ID is found, then it has to go to process 5, where I mentioned saying that it has go handle missing order IDs. and draft a response. Let's say if the order ID is not there in the email, it has to draft a response. And all these things needs a human intelligence to act according to different scenarios, right? It may not be the same scenario. If it's the same scenario, it's more of a rule based where you can solve with a simple automation. But here it is more subjective. It differs from one scenario to another. So you need a human intelligence to understand and then do it. And you will be using an AI here previously. And for that, you would have used an LLM model or anything like that. But here, along with an LLM model, if you are using other components that enables that human decision making to be more precise, that includes memories, reasoning ability, iterative reasoning, and all those components along with this, then it becomes an agentic solution. And I hope you understand how this one is differing from a traditional automation, right? So now you got what is the system prompt is about. And with the user prompt, you will be mentioning the arguments. But I'll tell you before getting to the user prompts, there is another section which is important to get configured. That is arguments. You can add input arguments where you might be receiving some argument from a RPA process or from another agent itself, like this, or it could be from an API or a connections, right? And you can pass an output of this agent to another agent or another automation or another API or anything or another tool through this output schema. And once you define this, let's say you are defining an input argument, pass your input text here and just giving this as a string, and we got these many types of arguments to create. And I'm clicking confirm. So you can see that my input is created as an argument. And now in user prompt, I'll be just mentioning this pass your input text as an argument in a syntax format. So whatever I'm mentioning here, same has to be mentioned in the syntax because it is very case sensitive, right? I'm not mentioning any text. If I want, I can maybe tell like you have to use the input from this argument and act according to the above system prompt, something like this. So that you're adding some natural text, but you really passing that argument also to it. That is what a user prompt is about. And you're not adding any further instruction or goal or role, anything to anything under the system prompt. Those has to be kept under system prompt. Clear? Now, so we have seen what are these general prompt and arguments. Let's look at the tools. That's what I was about saying, right? That's what I was saying just a few seconds before that. Apart from this prompt or LLM models that you chose so far, you are also enabling with some tools to act on it. And that's where it tells you to add either an agent itself or a process that is RPA like automation process or an Gen AI based activities. And you can add these, like these are the connectors which are available. And soon in the pipeline, they're also planning to bring some custom integration tools where you can build your custom APIs in the integration service and then you can tag it here. So for now, they have tagged with all those highly used APIs that are in there. So if I'm using Coupa, so I can get all the list of contract attachments. And then I need to establish this connection to Coupa. So then it gets connected through this connections, strings, and all the stuffs. And you can add any number of tools you want. I can add a box. I can add a box to this. And I can add another tool like a web search kind of thing. Web search, and I say if I can use Gina, I can use a reader. And I can use another tool like what else? Not box. Maybe uh, GenAI activities where I can make a web search. And you can use these GenAI activities to read through a web, or you can pass an URL, or you can pass. We were looking at one type of prompting, right? That is called React prompting, where you are enabling the agent along with the prompt with an external tool like a web search. And you can do that React prompting with the help of this web search, where it helps with the help of a Bing search APIs or Google custom search APIs, something like that. So you can add n number of tools. So what it does, it will try to, when you are running this agent, it will try to go through all these agents and get the best outcome out of it. And this is about tools. When it comes to context, right? So we were looking at another type of prompt that is so-called RAG, correct? RAG is something that you add a knowledge base to it. And then priming is something we also saw that, right? You're adding a knowledge base to it. But to enable that option of adding a RAG or a priming factors, you can use this context. And maybe if I have to explain this, I have to go a little bit deeper about what are the other options. But I would recommend you to go through the academy so that you will understand how this context grounding happens. So literally you will be getting through the admin portal and then you'll be enabling this context grounding. So that's how it works. So when you add that context grounding here to this agent, whatever question you are asking, apart from the tools that you have tagged to this agent, it will also look at the context and make a grounding, and then it will give you the most optimal response out of it. That is what this context will enable actually. Use context grounding indexes to provide your agent with relevant information. I hope you get that point now. And the most interesting and the most favorite part for me is this escalation and agent memory. Because if an agent is not working as expected, and if you want to assign it to someone to just validate it, you can use this escalation center. And apart from this escalation, you can also add a memory layer to it. And that is what is agent memory is about. You can enable this agent memory, and it's still in preview. It's not completely enabled. And you can add your escalation templates, like you can create the escalation templates. When I say templates, it's like, let's say the agent is not working as expected, and you want to notify someone in an app kind of thing. For that, you can create an app with UiPath apps and publish that as a template, and you can refer that template here so that if something goes wrong, it creates an escalation through that app and notifies that user so that the user will get into that app and then see what needs to be done and then close that escalation. So this is something that Agent Builder is being made with. There are many other features, and it'll hardly take another 1 hour to explain all these features. But we have down the line with some couple of sessions to explain about Agent Builder and then how it would be. But you will be able to understand more once this gets into the public preview, right? And apart from this, you have got the evaluations to see how this evaluation is, I mean, how the agent is performing. And then you can get the traces. And then you also see the health score of how the prompt is, how the tool is, how the input schema is, and evaluation, all these stuffs. And you can literally export this agent and then you can use it outside this agent as well, which means I can build this agent, I can give it to you, we can import, and then you can use it. And the best part is you can invoke an RPA automation to an agent. That is what you saw in this tools, right? I'll just quickly get to that part. You can add another agent, or you can add an automation, RPA, or you can add a tool like a web search or an GenA-based activities or any API tools, API connections to a tool like Coupa and Jira, like that. So this is how you build an agent. And then out of all these tools and context, all these will be used by an agent based on how you are giving a prompt. So your prompt plays a very, very crucial role, and it's really important to understand what type of prompt you're giving under the system prompt and user prompt. So I hope this session would have given you a clarity about that. And when you get into this agent builder, you will understand how to give a system prompt and how to give a user prompt. So I want to get back again to this one so that with this, you can take a screenshot of this. So under the role, you can write a normal text. You can cover a role with hash at both the side. We have to literally mention that hash, and that's how it is. And then you have to mention goal and instructions covering. I have here, like mistakenly, have mentioned one hash at one side. Ideally, it has to be both the sides when you are mentioning it in Agent Builder. So in under the user prompt, you can pass the input variables, something like this with the double curly braces. So with that note, I I would like to end up this session, but I'm pretty sure that you would have got more curious about this agent builder, and there is another project called Agentic Mastro, which will help you in terms of building agent workflow, because this agent builder is focused more on building an agent for a specific set of tasks. But if you're combining multiple agents with the whole large scale process with the other steps which are available, and then it comes under agentic workflow. And to build an agentic workflow, you'll be using Mastro. That is a tool name coming from UiPath. All these are getting launched just by day after tomorrow. So I'm also excited to see how it is going to be and hope you're also on the same line. So we'll catch up in the next set of sessions with further more details. And you can reach me through LinkedIn. I'll just end up with just this one with a QR code. You can scan this and then you can reach me through LinkedIn at any time. So thank you. And Vidya, over to you.
Thank you, Palani. It was nice having you here. To answer James' question, this entire session is recorded and the recording will be available by Wednesday morning. You can go ahead and check the recording, and there the entire PPT will be like recorded. So you can get the points from the PPT there. And let me share my screen. Okay, before I share my screen, we have another series coming up. I'll share the link with you guys. Kaushik, can you please share the upcoming sessions?
Sorry, Vidya, was it to me or?
Oh, no, it was for Kaushik. 1 second, I'll go ahead and do it.
Yeah, thank
These are the links for the upcoming series. And in any case you have missed the previous sessions of Palani, the recording is also included in the link. Please go ahead and take a look at it so that you will understand this session better. And also there are other recordings out there in the community where you talk about agent building. You can go ahead and refer to that. Now I'll share my screen.